Find the intersection of the lines f of x equals 3x minus 2 and g of x equals 6x plus 4, and also graph the two lines. So we're going to look at how to find the intersection of these lines both algebraically and graphically, see that we come up with the same solution either way. So first, if we're thinking algebraically, when we're thinking about the intersection of two functions, we're really looking for when is our function f of x equal to our function g of x. So this allows us to write an equation that we can solve. So we want to know when is 3x minus 2 equal to 6x plus 4. So we can start by subtracting 6x from both sides. So we have negative 3x minus 2 is equal to 4. Adding 2 on both sides, we have negative 3x equals 6. And finally, as we divide both sides by negative 3, we get that x is equal to negative 2. So this is the input value that causes our two functions to be equal. If we wanted to know the output value, we can take this negative 2 and plug it into either one of our functions. So if we were to evaluate f of negative 2, we have 3 times negative 2 minus 2. So that's negative 6, take away 2, which is negative 8. But notice if we had done g of negative 2, so 6 times negative 2 plus 4, we have negative 12 plus 4, which is also negative 8. If we compare this to what we would find if we looked at these graphically, so first let's look at graphing f of x equals 3x minus 2. So this is a linear function, so a line when we graph it. The negative 2 is telling us where we cross the y-axis with our y-intercept, so they're at 0, negative 2. And the slope of 3 tells us that this line goes up 3 and then right 1, up 3 and right 1. If we wanted additional points, we could also go down 3 and left 1, down 3 and left 1. And then just a straight line connecting our points. For our line, g of x equals 6x plus 4. So the 4 this time is telling us about our y-intercept. This one has a slope of positive 6. So a slope of positive 6 goes up 6 units and then right 1 unit. So to get additional points, we could also go down 6 units and left 1 unit, down 6 and left 1. And if we were to draw a straight line through those points, what we notice is that the intersection point of these two lines is that they intersect at the point negative 2, negative 8, the same values that we found algebraically when we set our functions equal to each other. So algebraically, when we set f of x equal to g of x, it told us the input value x that caused the outputs of these functions to be the same. So when the input is negative 2, they have the same output of negative 8, or graphically, this tells us that our lines intersect at the point negative 2, negative 8. So for an input value of negative 2, they both have an output value of negative 8.